I request the keynote speaker to present the whole 25 minutes, followed by 2-3 questions. Yeah, first speaker is Professor Tetsuya Ishikawa from Hokkaido University. So please start.
Thank you, Chairman. Good afternoon, everyone. I'm Tetsuya Ishikawa from University from Japan. First of all, I'd like to extend my sincere thanks to the organizing committee of the Geotech Asia 2025 for inviting me to this exciting conference. I'm so pleased to be with you and so honored to have an opportunity to introduce our research. Today, I'll be talking about this slide. This is the table of content of today's my presentation. In this presentation, I would like to introduce the three prediction methods for the random-induced water-soil compound geodisaster with different time scales, such as the territorial scale and catchment scale and local scale. So first, I'd like to introduce the background of this research. The segment disasters such as the shallow landslide and the debris flow occur widely and frequently in Asia. Torrential rainfall from all kinds of the sources, such as the typhoon and the rainy season, is one of the main causes. Besides, the IPCC forecasts that the frequency and intensity of the torrential rainfall are expected to increase and increase as the extreme weather events become more frequent in the future. Therefore, it is very important to study the mechanism of rainfall-induced landslide with the consideration of the nano surface flow for better hazard control in the near future. For example, in Hokkaido is a northern island in Japan. The number of torrential rainstorm over the 30 millimeters per hour is increasing like this figure. In general, in case of the rainfall intensity over the 30 millimeters per hour, soil ground cannot absorb the all rainwater, and the surface water flow on the ground surface. Therefore, by the end of this century, Hokkaido expects to have more rain and more weather disaster with future climate change. In this case, how should we assess the impact of climate change on the slope stability in the future? Please note that this table is from the Japanese Meteorological Agency. Please note that in general, in case of the rainfall intensity over the 30 millimeters per hour, soil ground cannot absorb the all rainwater, and rainwater begin to run off onto the ground surface. Therefore, this assessment for the heavy rainfall-induced slope failure should be done by considering the rainfall infiltration and surface runoff. Then, I'd like to introduce the runoff-induced water-soil compound geodisaster. What is it? This slide introduces one example of the runoff-induced geodisaster during the torrential rainfall. Rainfall that fell on the plateau flow down the slope, causing the slope failure, and also flow down along the road like this, moving and toward the valley, scarring the sidewalk and finally causing the slope failure at the flow end. In this case, the flow network of the runoff water should be analyzed for the damage reduction of the geo-disaster along the road. This is another example of the runoff water triggered catastrophic landslide in Hokkaido. In this geo-disaster, as shown in the figure, many serious slope failure occurred at the cross point of the flow path and road network. This is because these factor the accumulation of topography of the surface flow and seepage flow. If the rainfall intensity is higher than the infiltration capacity of the ground, rainwater that cannot infiltrate into the soil ground flow down ground surface. Therefore, the risk of heavy rainfall induced slope failure should be evaluated by considering the both surface flow and seepage flow. And in addition, these figures show that three previous serious landslide occurred in Hokkaido. In these geodisasters, significantly long soil runoff, such as shown in this figure, observed, leading to a wider damage area than the failure area. In this case, water lubrication is considered as one of this phenomenon, the reason of this phenomenon. So, therefore, in case of the heavy rainfall-induced slope failure, in addition to the slope stability analysis, it is important to conduct the soil runoff analysis to capture the post-failure behavior, such as the transportation path and deposit site of the collapsed soil. Then, maybe research objective. Keeping in mind these key points laid in the introduction part, this study introduced hierarchical territorial risk assessment method for the compound water soil geodisaster under extreme weather conditions. For this end, in this study, I would like to discuss the following two research topics in this presentation. To develop the risk assessment method for the rainfall-induced slope failure with the surface flow, we propose hierarchical territorial risk assessment for the compound water soil geodisaster by using multi-phase and multi-scale analysis as shown in this figure. This method consists of the three scale level. Level 1 is a territorial scale early warning system for extracting the alert mesh. Maybe in Japan, we announce the warning information 1 kilometer by 1 kilometer mesh. Then maybe this is the minimum area in Japan. So, and level 2 is the catchment scale slope stability analysis. Or maybe if we do the very high performance computer, maybe we can do the numerical estimation 1 kilometer by 1 kilometer. Then maybe we do this kind of computer estimation. And the last one is level 3, local scale soil runoff analysis. Maybe in this case, maybe we will estimate the disaster-prone area. First, to evaluate the applicability and usefulness of the risk assessment method proposed in this study, I would like to introduce the actual slope failure case using the introduction analysis in this presentation. First case is a slope failure in the Nishio Pass area in August 2016. Extremely heavy rainfall caused several serious roadside slope failure. So along the national highway, as shown in this figure, at the seventh stage of the Nishio Pass, erosion and degradation induced by the runoff cause a large-scale collapse like this. Owing to the considerable damage, this highway was closed for approximately 1 year. And next, second case study is a slope failure in the Shikos Lake area in September 2018. From the September 5th to 6th, 2018, there are two types of the slope area close together before and after the very serious earthquake. Case 1 is caused by the heavy rainfall before the earthquake, and case 2 was caused by the earthquake after the rainfall. Then go to the first scale level. Maybe I would like to discuss about the territorial scale geodisaster early warning information system. At first, I'd like to briefly introduce the territorial landslide early warning system employed in Japan. The Japanese government initiated the new nationwide early warning system for the geodisaster in 2005. The early warning system is a comparatively novel numerical model for the rainfall-induced shallow landslide. And based on this system, Japanese government announced the sediment disaster warning information and evacuation information to the residents in the dangerous area. In Japan, in the Japanese early warning system, outbreak of the geodisaster is assessed by 1 kilometer by 1 kilometer mesh, and by checking whether the snake line as measured and predicted rainfall amount, the snake line is consists of the measured and predicted rainfall amount, exceeds the threshold line named critical line, maybe here. So in this case, maybe the snake line exceeds the critical line, then maybe the slope area occurs. Maybe in this system, maybe there are two rainfall. One is 60 minutes rainfall amount, and the other is soil water index. Soil water index is a conceptual model of the availability of the moisture of the surface soil calculated using the value of the total water depth of the three-layer tank model like shown in this figure. Therefore, the soil water index provides the estimation on the average amount of the water stored in the soil of the certain area, helping to clarify the risk of the landslide related to incident caused by the heavy rain. So then, maybe next, I would like to verify the applicability of the Japanese early warning system by confirming the relationship between the critical line and snake line. In both the slope area case, the snake line exceeded the critical line near estimated time of the slope area. This indicates that the Japanese early warning system appropriately detects the occurrence of the slope area, even in the landslide caused by the heavy rainfall, where the surface runoff was observed. This demonstrates the applicability of the Japanese early warning system for the territorial scale risk assessment method for the rainfall-induced landslide disaster is sufficiently high. Maybe we can use this Japanese early warning system to predict the heavy rainfall-induced landslide, regardless the existence of the surface runoff. Furthermore, interestingly, in case of this figure, maybe the snake line might reach the critical line 2 times which indicate that the small-scale slope area occur first. After that, maybe the large slope area occur. So, using this kind of prediction method, maybe we can correctly predict the occurrence of the slope area. However, maybe this is only for the 1 kilometer by 1 kilometer. So maybe we do not know the correct location of the slope area. Therefore, maybe we need to do catchment scale hybrid coupled slope stability analysis. To develop the risk assessment method for the inflation type slope area with surface flow that of Finland, rainfall intensity exceed the infiltration capacity of the soil ground. We employ the hybrid coupled model of the surface flow and subsurface flow and soil mechanics as shown in this figure. So, the effect of the surface water flow is usually neglected in the traditional slope stability analysis. When using this method, we can examine the effect of the surface water flow on the local safety factor of the soil element by analyzing the runoff, infiltration, and slope instability simultaneously. This is an example of the numerical simulation of the actual slope area over the seventh stage of the initial pass. Due to the limitation of the presentation time, I need to skip the detailed explanation of the FA analysis. But in this case, we use the 1 meter mesh TEM to model the slope area. This slide shows the hydraulic behavior of the simulation site. As shown in this figure, rainfall intensity increases, infiltration capacity gradually decreases, leading to the generation of the surface runoff. When the rainfall intensity exceeds the infiltration capacity here. Seeing this figure, due to the local topography, most of the runoff concentrate at the valley exit, like location 1 and location 2, and water continuity observed on the road, which is consistent with the field observation. And runoff also is that the large pressure gradient on the surface, causing a significant infiltration. Therefore, maybe we can observe a rapid increase in the pore water pressure as shown in this figure. This slide shows the mechanical behavior of the simulation result. As shown in this figure, local safety factor rapidly decreasing like this, with the increase in the pore water pressure after the surface runoff generation. This indicates the adverse effect of the surface flow on the slope stability. Besides, as shown in this figure, the location and the length of the estimated danger spot by numerical simulation agree well with the field investigation. However, though the landslide with a shallow depth at the location 2 can be well reproduced. However, in case of the location 1, due to the neglect of the progressive slope area mechanism and surface erosion caused by the high velocity surface flow, the depth of the slip surface is underestimated. Actually, as shown in this figure, the maximum runoff velocity at location 1 is greatly exceed the critical erosion velocity. while it is noted that the excess at the location 2 is small. This slide shows the simulation result for the Shikos Lake area. Trend of the simulation result is similar to the initial path. However, simulated unstable zone is closely matching to the field condition, unlike the location 1 at the initial path. This is because in this case, run-off velocity briefly exceed and exceed the critical erosion velocity, while both magnitude and duration of the experience are smaller as compared with the location 1. This means that the occurrence of the surface flow erosion is limited, like location 1, location 2 at the initial path. Consequently, the surface runoff plays an important role in promoting the rainfall water infiltration and triggering the slope failure. And these numerical simulation results also demonstrated the capability of the catchment scale hybrid coupled slope stability analysis to accurately identify the occurrence spot and dangerous area of the heavy rainfall-induced slope area. Finally, go to the third scale level about the local scale slope stability soil runout integrated analysis. To develop the risk assessment method for the modeling the complex dynamic behavior of the post-failure soil water mixture, considering the surface flow and subsurface flow under heavy rainfall, maybe we employ the slope stability and soil runout integrated analysis as shown in this figure. In this study, we integrated the slope stability analysis with the soil runout analysis using the depth average equation to study the slope failure and subsequent landslide transportation process for more computational efficient in the large-scale complex phenomenon.
Sir, 3 minutes.
Okay. Actually, in this flowchart, maybe the first step is the slope stability analysis. This is the same as the former section. And the second step, the next step is the soil runout analysis. So, using this kind of explanation, maybe we can evaluate the soil runout failure. So, this slide shows the first case study that is initial path location 1. The numerical model and the material flow parameter for the soil runout analysis is shown as follows. As the slip surface is underestimated in the slope stability analysis, therefore, maybe area with local safety factor less than 1.2 is selected as the initial landslide path. So, and also maybe reduction coefficient of the burst facial shear resistance is set to the 0.01 to reduce the transportation cost in the soil runout path. And this is the result of the S1. In case without reduction of the shear resistance, no obvious soil runout behavior is observed. However, if we use the reduction coefficient, maybe soil runout simulation can successfully reproduce the soil runout process photographed by the UAV, which demonstrates the effectiveness of the calculated parameter. And this is the second case. And this is the simulation result of the case study of the Shikos Lake case 1. Just like those in the surface area in case of the only reduction quotient equal to 0.56, soil laminar simulation can successfully reproduce the actual transportation path and thickness of the collapsed soil table. Maybe this demonstrates the effectiveness of the calculated parameter. Based on this discussion, the maybe importance of the surface landlock appear not only in triggering the soil area, but also both amplifying the post-area mobility through the mobility and increasing the landslide volume due to the erosion effect. Accordingly, the development the surface landlock
Conclude?
Yeah, conclude. Okay. Maybe we should consider the landlock effect. So maybe if we want to use this kind of investigation, maybe we can use these relationship. Maybe the reduction of the local safety factor and the reduction of the shear resistance is closely related to the landlock velocity and landlock density. Now let me summarize my talk. This study introduced the hierarchical teleorder risk assessment method for compound water soil geodisaster, and applicability and effectiveness were examined through two case studies of the extremely heavy rainfall induced geodisaster occurred in Hokkaido, Japan. As a result, following the finding of the digital time limitation area in scale. So, maybe this kind of numerical study is very important for the near future. Maybe because maybe we have the many times the heavy rain, and also the intensity of the heavy rainfall is increasing. So this is a list of the difference. Maybe you can find the detailed information in these papers. That's all. Thank you for your kind attention.
Thank you, Professor, for nice presentation. And we can take one or two questions. If you have any question, kindly raise it. And no more questions. We will thank Professor Tatsuya preparing this wonderful presentation covering overall aspects of the rain-induced slope instability. Thank you.
We now request the chair and co-chair to present the speaker with a memento of our gratitude and appreciation. Thank you, sir.
Good afternoon. We'll move on to the next presentation. Next keynote presenter will be Dr. Mandeep. Dr. Mandeep Subedi, President of Nepal Geotechnical Society, and he will be presenting a talk on a decade after the 2015 Carlos earthquake, resisting reassessing the parts readiness for future seismic events. You have 25 minutes and we are giving 5 minutes for Q&A session. The floor is yours, please.
Thank you. Good afternoon, everyone. Namaste. Chair of this session, Professor Bhuminathan and Professor Madhu Kumar. First of all, I want to thank all the organizing committee and IGS for providing me this wonderful opportunity. My topic for today's presentation is a decade after the 2015 Gorkha earthquake, reassessing Nepal's readiness for future seismic events. Here, I will try to reflect on Nepal's experiences and key learnings from the 2015 Gorkha earthquake and the 2023 Rajagora earthquake. And I will discuss how we are preparing ourselves for future seismic challenges. I believe our experience and learning can be a good example for the developing nation like Nepal, and the discussion here will guide us how the improvement need to be made for a sustainable society. The presentation is based on my previous studies and the research work done in the various times. I would like to thank all my team members for their contribution. This is the content of my presentation. I will briefly explain about the Nepal, its geology and seismicity. I will take you the disaster tour of 2015 Gorkha earthquake and 2023 Rajagora earthquake. Also, we will talk about the learnings from Nepal and we will conclude with some way forward. This is the beautiful country, my country Nepal, and it looks like the sandwich between two large countries, India and China, with the average length of 800 kilometers and north-south distance of about 200 kilometers. I believe we all are aware about the tectonic movement of this region, Hindu-Kush region. And the Indian plate is moving northward towards the Eurasian plate at the rate of about 1.8 to 4 centimeters per year, depending on the specific location and the measurement methods. Average convergence rate near Himalaya, that we mentioned near Nepal, is around 4 centimeters per year. This results the formation of beautiful mountains and Himalayas. World's eight highest Himalayas, including Mount Everest, is in Nepal. And the interesting thing is these Himalayas are the freshwater source of about 1.9 billion population. That means 1/4 world population. These are the largest source of fresh water beyond the polarities. These pictures show the natural beauty of Nepal. You can see the Himalayas, our glacial lakes, settlements. And this is the photograph of Pokhara. In a single frame, you can see the place of ranging from 250 meter height from mean sea level to above 8,000 kilometers. Beautiful lake, flatlands, mountains, and also the Himalayas. Okay, from the beauty and the sceneries, now I want to take you towards the earthquake and the disaster. This Hindu-Kush Himalaya region extends across the country from Afghanistan to Myanmar, almost 8 countries, forming one of the most seismically active mountain belts on Earth. This region is very vulnerable to the seismic event. We have experienced large earthquakes in last 100 years. There are many fault zones across the country. Here we have main frontal thrust, main boundary thrust, main central thrust, and Tibetan detachment. Among them, the main Himalayan thrust, especially the MFT, main frontal thrust, is the most active and hazardous fault zone in Nepal. This is responsible for the large earthquake like 1934 Nepal Bihar earthquake and 2015 Gorkha earthquake, and likely future the large events. This image shows about the past earthquake on this region. Here you can see in the past 100 decades we have the earthquake which have magnitude more than 8 magnitude, and the eastern part of Nepal has a seismic gap of around 600 years. This isn't just the knowledge gap, it is the seismic time. The Dadalkot earthquake may be the stress whisper. The next mega thrust could be catastrophic. Okay, let's not be panic, but we need to be aware and alert. This is the disaster perspective of Nepal due to risks of long, steep and fragile mountains. During the time of earthquake, we had the risks of liquefaction in the valley and the Tarai region. We have the risks of landslide in the mountains and Himalayas. We have the risks of Gulf and also the risks of avalanches, and all the disasters have the cascading effect also. Now let's travel to the Gorkha earthquake disaster. This is one of the monuments of Nepal. It was built almost 200 years ago, and it was built for the military purpose and considered as a kind of the monument of pride for the Nepalese. And it was totally demolished during the earthquake. And Gorkha earthquake had a magnitude of 7.8 magnitude, and it was 8.2 meter depth, and it was almost 76 kilometers west of Kathmandu. During the Gorkha earthquake, due to the variation of our geological features and also the various type of land, we experienced liquefaction, valley effect, ridge effect, landslide. We had avalanches, rockfall, all types of disease effect we experienced in the Gorkha earthquake. This caused the structural damage, geotechnical effect, and at last the social cause. Here you can see the buildings in the rural area who were with the mud and stone joint are damaged totally, and in the back side you can see the signals of many landslides beyond these houses. This is the photograph near the Kathmandu Valley, in the countryside of Kathmandu Valley. The side one picture. This picture shows the liquefaction that was occurred in Kathmandu Valley. This shows the landslides, and this is the land subsidence in the Kathmandu. This liquefaction had occurred in, this is the library of Nepal Engineering College, this library building, and this building was affected from the liquefaction. The oil is totally filled with sand, and in this picture I am testing how was the soil condition after the Gorkha earthquake. In the Gorkha earthquake, the peak ground acceleration was not as much as expected. It was only 0.183, although we experienced the signs of liquefaction in 18 places. And after calculating the factor of safety with the borehole data of around 400 numbers of borehole data of Kathmandu Valley, the points where the signs of liquefaction were seen lie on the zone of high risk zone. And so this shows that if we have the earthquake of larger PGA, we can experience the liquefaction in the larger part of Kathmandu Valley. This is the places where we had liquefaction, and the borehole of that places, we can see SPT value of these places is very low. And these are the places in the mid-city, liquefaction, land subsidence, and the buildings are tilting, although they are structurally, they seem stable, but due to the land subsidence, they are tilting here and there. This is in the Thamel area of Kathmandu. Thamel is a touristic place, where all the places, the place is full of hotels, and the buildings were tilting in this way. We had also this is the example of the ridge effect. The buildings in the ridge are damaged, but the buildings here nearby the ridge are away from the ridge. They seem they have low effect and they are safe also. And this is the place, Barma, near the epicenter. You can see it was a good touristic place and a homestay place. All the buildings in this village are totally damaged. And here are some RCC structures in between these old historic machinery buildings, and these buildings were safe after the Gorkha earthquake. Only the historic machinery buildings were damaged. What we did a good reconstruction. We showed the globe that we had completed the reconstruction in a good way. We almost reconstructed 90% houses. We trained more than 3,500 engineers for the retrofitting, and also we produced the skilled manpowers. This was our progress. And we also revised the National Building Code, and this is the seismic zoning map of Nepal. And according to this map, we can see that we are expected to have the PGA of 0.3 to 0.4 in almost the areas where there is higher settlements. And this is the example of photo that we have constructed after the reconstruction of a beautiful house in the countryside in Kathmandu. And Dadar earthquake, I call it as a bad reminder, because we said to the people, to the globe, that we have first in a good way. We did the reconstruction. Now we are away. We have trained the many engineers. But almost after 10 years of the Gorkha earthquake, the same situation happened. Now let's took the tour of the Dadar earthquake, which was a little bit small, very small compared to the Gorkha earthquake, only of 5.7 magnitude, and the effect was almost in the 10-kilometer area. In the 10-kilometer area, also almost all the buildings were damaged. In this Dadar also, the big ground acceleration, we do not have too much recording station, but the station nearby, we find that the big ground acceleration was not so, it was less than 0.1 G, and we had also ridge effect, basic effect, local site effects, all in the one place. Here you can see the ridge effect, the settlement were basically in Nepal, the settlement are in the ridge and some in the valley riverside. The buildings in the ridge are totally damaged at the time of landslide, earthquake also. And here is also the examples of this effect. This is of the Barak holding sites in the area of near Dadar. And here also, in this picture you can see this is the Rimnaga, and here the highest number of people died in this village, and it was nearby the river, and here we had the basin effect. This is also another example of the basin effect. And we had also local side effect. The river deposit village, there were some river deposit villages, and in the place where there was a river deposition, the structures established in these deposits were highly damaged. We experienced more than 160 landslides at the places. These are the landslides that we measured in the field. Here our team is measuring measuring the size of rocks that fall on the highway. We are measuring how is the condition of highway, this is medium highway, in the time of that Dadalpur earthquake. These are the structures that fell due to the Dadalpur earthquake. And the roads have also subsidence failure there. And this is the part we take for the survey of this area. And these are the typology. With the so small earthquake, almost 100,000 of buildings were collapsed, and most of the buildings which were masonry structures are damaged totally. And in Nepal, these are the main typology of buildings we have in Nepal. RCC structures, but not engineered, and some good masonry structures and Arab architecture. These are the type of structures we can find in Nepal. And most of the masonry structures are totally damaged. Dadalpur earthquake too. Here you can see the different types of failure of the structures. I will read fast. The damage of masonry structures, roof failure, and supporting wall of buildings. And damage of masonry building out of plain collapse of stone masonry wall. And there we can also see the masonry walls are damaged. And this is one of the historical building, almost constructed 600 years ago. It's the palace of the king. There were many kings in the country, small states, and it was also almost damaged. And you can see that a beautiful village. It seems to be safe, but most of the buildings are not suitable to stay. And for the RCC building, they are safe, but some of the points and some of the joints were cracked, but they were safe to stay with the minor maintenance. And these are the school buildings. In this area, most of the school buildings are in this condition, and the buildings which have the RCC framework, they can be used after some maintenance, but the masonry buildings were totally damaged in the Dadalpur area too. There was a bridge, only one bridge in that corridor, RCC, only one RCC for stable RCC bridge. The deck, the slab of the bridge was shifted by some around 2 inches. It showed that how such a small earthquake can shift the deck of the bridge. This is the example that the different geotechnical effect, ridge effect, valley effect, or that can influence the vibration or seismicity. This is one of the examples, just the so low PGA and so low magnitude, but it shifts the deck of the slab of the bridge, RCC bridge. And we were proudly saying that we did a good example after the Gorkha earthquake. Sometimes we used to say, we can also be like Haiti, because after the Haiti, the reconstruction was not good. And after the Gorkha earthquake, we were proud that we did it. But when we see this photo after the Dadalpur earthquake, it is almost same after 2 hours or so. And we have not started the reconstruction. There may be the different causes. One of the causes may be people are waiting for the help as they get into work hard. And also another cause means people are not aware of what to do. And so some people are not enough to make the houses, but the people who have money also, they may be waiting for the government. But we are not being able to reconstruct in the Dadalpur area. From this, these are the typology of building, stone masonry, made of non-RC and engineered structure. If we look at the table, comparative chart, we can see engineered structures are have performed good. The structures who have complied the code in a good way, they were absolutely good in Dadalkot earthquake and also the Gorkha earthquake. But the stone masonry walls, which were not engineered, which were not made in a good way, are 80 to 90%. And this is the illustrative hydrogenetic part, which shows the result as I have shown earlier. And when we discuss about the landslide pattern, this is the earthquake magnitude versus landslide graph suggested by the USGS. But in Nepal case, we got, although the mountains were young, and also they were very still, the numbers of landslide are less. It may be due to, because both the earthquake were not in the rainy season or just after the rainy season, it may be due to that reason. But it's sure that the landslide occur in so fragile region is lower than it was expected. And talking about the groundwater table, we have the fluctuation groundwater table. Nepal's mostly populated area in the valley and in the Tarai belt depend upon the groundwater, and the past research showed that the groundwater rises, but in Nepal case it was very from place to place. It showed that Nepal has a very much difference in the geology. It has not, we cannot generalize all the conditions at the same time. And this is the research done by Jimeli School, and we can say not only we have the geotechnical structural effects, we have the social effect. Most of the people were displaced out of the earthquake. People are having the trauma and with the low preparedness, and community are not feeling resilient, and this is the bad side of our thing. And the good thing is, we made the constitution in 2015 after the Gorkha earthquake, so we have put the thing of DRR in our constitution. The preparedness, rescue, relief and rehabilitation is the responsibility of the state. And yeah.
3 more minutes.
Thanks. And the priority goes to all the level of governments. And at that time, we had construction. We had the institution, National Reconstruction Authority, and it was independent body. And so, I think with the help of NRA, we had succeeded to do this work. Being the independent body, we have succeeded to do the work in the good way. And now we have constituted National Disaster Restoration and Management Authority. It is not. It is also the independent body, but not functioning so well. But it has a different organization from local body to the central body. And also, after the disaster, Nepal's academic institution started the earthquake engineering course, disaster course in the different universities. Before the earthquake, we had the higher study. Very few researchers were done in this sector, and also we society are also responsible for this type of disaster. And Nepal Society, Nepal Engineers Association trained the system to the damage result assessment of 65,000 buildings voluntarily. And the most thing we learned is the people of Nepal, after the disaster, have hope, faith and trust towards the engineer. And there are some, these are the causes why we could not, what was the disconnect between policy and implementation, why we were failed in Dadalkot earthquake. And Nepal Theatre Society has also done many works for the disaster preparedness. This society is preparing the geotechnical building code for Nepal government. We have different awareness program, knowledge sharing program, capacity program. And after the Gorkha, we realized that we have to call the different institutions, different people from the globe. So we started to organize the Geomandul. This is the photo of Geomandul. President Mark Baloch was also virtually present in 2023 and physically present in 2024. Thank ISSMG and Carlos and also Professor Shah for the support. And this is we developed our GeoHazard course together with the BGC Engineering Canada. This course is very nice course, and the Asian Development Bank I have taken this course curriculum as the best course. I am implementing to the Bhutan and other countries also. And thank you. 1 minute. Okay. And these are some programs we have been in Nepal, and we know we are working for the residents. And for this, we have to build our capacity. To build our capacity, we have to be strong from our side. So thank you for listening me. And I would like to take this opportunity to welcome to the next Geomandu and 17th AYGC to Kathmandu. Thank you.
Thank you, Dr. Nandi. Our interesting lecture covering two major earthquakes, of course, that also very impact in India also, not only Nepal, neighboring states in India also affected. We can take one or two questions from audience. Any questions are there? Otherwise, I have two questions. Okay, the first question is related to liquefaction. During 2015 Gorkha earthquake, you shown that some figures liquefaction occurred. Could you please explain the depth of liquefaction, how far it is from the epicenter, whether it is close to the epicenter or it is away from the epicenter? Some more details.
Yeah. The liquefaction sign we observed or we studied about Kathmandu Valley. It was almost 76 kilometers from the Kathmandu, and as Kathmandu is a lake deposit, and the liquefaction signs were shown in the 26 places of this small valley, and the depth was around 3 to 4 meters.
The second question is about the next earthquake, that is 2023. That got it. Yes. This is 2023, yes. Another earthquake.
Yeah.
You also shown that the effect of ridge effect, basin effect, local soil effect.
Yeah.
Which are the effects caused major damage? Among three.
Actually, this place is very remote place of Nepal, and almost all the buildings were masonry structures. The buildings which were in the ridge, damaged, collapsed. Almost all were damaged. The buildings which were in the valley, they were also damaged, completely damaged. And when you see the bridge, it has shifted. You can see the local side effect also. So,
otherwise, it depends on the location. Or you cannot generalize. This is the major.
yeah, I think all three are equally responsible.
Thank you.
Sir, one more question. Namaste, sir. Sandeep sir here. This side. Myself, Yojana from Maharashtra.
Yeah.
We are having landslide issues, Marin, then Mahad, as well as Irsalgarh. There, in the rainy season, severe landslide always happens. Even in Maharashtra, Killari earthquake. So, is there any relationship between rainfall and this landslide and earthquake? Because as we are having early warning systems, and we can predict the rainfall forecast, but likewise, can we predict this earthquake and landslides?
Yeah. We are also, our team is doing this research also. After the Gorkha earthquake, almost 2 years later, the numbers of landslide in the monsoon increased so fast, almost double the numbers it was previous. But there are also other causes. In Nepal, is developing the road, massively developing the roads. In last 20 years, it developed it roads 5 times. So this may be also the cause. But I think the cracks made by the Gorkha earthquake, we are seeing the effects later in both types of events. Thank you.
Thank you, everyone.
Thank you very much, sir. We now request Dr. Sunil Basarkar, sir, the Organizing Secretary for Geotech Asia 2025, to present the mementos to the chair and co-chair, and also request the chair and co-chair to give the mementos to the speaker. Thank you. Thank you, sir. Dr. Sunil Basarkar, sir, presenting the mementos to the chair and co-chair for the session. Thank you.
Yes, I request Professor Tukumaran to summarize the session.
With that, we have come to the end of plenary session 8. In this session, 2 papers have been presented. Both are very interesting and informative presentation. Professor Gio has presented about rainfall-induced landslide, and he has emphasized 2 important case studies based on 2 lines, CL and SL, critical line and snake line. And he has also very beautifully explained about the hierarchy of the assessment pattern, especially for heavy rainfall-induced landslide analysis, local analysis, catchment area analysis, and regional analysis, how that has been transformed to the hierarchy and selected with respect to problem specific. So that was a really very interesting lecture. And personally, I like the terminology which he has introduced, weather disaster. Just the first time I'm hearing this terminology. We are all very exposed to the geo disaster. Professor Kashia introduced weather disaster. So overall that it was a very analytical related aspect compared with field exposure. So given a vast experience, source is vast experience on this area, and probably the study has done more than 10-15 years is a collective effort, and especially the modification in shear strength, considering infiltration and exfiltration, how the shear strength has been affected, and that has been critically evaluated and has been included in the constitutive model. I really thank for such a wonderful and interesting topic on that particular area. And the second topic, Dr. Mandeep has given, it is a colorful presentation, and it is, in one line I can say that it is successful failures. So that is what they learned stories, lessons from past 2 earthquakes in 2015 and 23. So based on these lessons, they have 2020 Nepal National Building Code has been modified with respect to seismic zone, and that has been taken care in the building code implementation practices are following that process. But nevertheless, still they have seen the failure in 2020, the earthquake, but it is a continuous lesson, and lesson will be taken further and it will be reinforced in their earthquake resistance structure. So we believe that these two lectures have been very informative on the chosen topic and enriched in a domain area knowledge. With that, we conclude this session, and on behalf of Chair and Co-Chair, we thank the organizing committee for giving this opportunity to share the very important plenary session. Thank you. Over to the
Thank you very much, sir, for summarizing very nicely. I now request Professor Hemant Hazarika, Kyushu University, Japan, as he has a quick announcement to make.
Thank you very much. I'm on this stage for the third time. Probably most of you are bored of seeing my face. But I'm a free bird now because I don't have timekeeper this time. No timekeeper. So let me give you 2-3 minutes of a conference announcement. Okay, I'll not take so much time. This is called CRAST. CRAST stands for Construction Resources for Environmentally Sustainable Technology. The first CRAST was held in Fukuoka, which was unfortunately online due to COVID-19, and it was attended by 185 delegates from 34 countries from almost 5 continents. And the second one was held successfully with the support from President Park, who delivered his opening lecture online. Unfortunately, he couldn't come. And also Professor Keiji Sho, he came and delivered his lecture, as well as he was there all the time. Thank you, two of you, for supporting CRAST 2023, which was, of course, Professor Askar also joined CRAST and he was there until the end. And it was a very well attended conference with 411 delegates from 25 countries and covering 6 continents. And the next one, next CRAST will be held in CRAST 2026, will be held in University of Cambridge. Professor Stuart Higg is taking the chairmanship for this conference. The abstract for the deadline for the abstract is already over last month, but we are very flexible. We still have slots, so please contact me or Professor Stuart Higg for if you want to submit abstract. Okay? We have a few keynote lectures from different parts of the world already decided, and a few have to be decided. So I'm sure you'll like the University of Cambridge campus and the Cambridge city as well. So I welcome all of you to CRAST 2026. Thank you very much.
Thank you, Professor Hazarika. So before we move on to the panel discussion, I have 2 more announcements to make. The mini workshop which was announced earlier today on sustainability practices for smart geotechniques is to be held at 3:45 p.m. in all day, all night room. And the other announcement is that all the delegates who have registered for today's gala dinner are requested to assemble at the hotel lobby at 6:45 p.m. sharp. So thank you for allowing me to make these announcements. We now move on to the panel discussion, Geotechnical Engineering in a Changing World from an Asian Perspective, featuring presidents of Asian Geotechnical Societies. And I now invite the moderator, Professor Yi Jian Shu, Vice President Asia ISSMG, to take up the proceedings. Please welcome, sir.
this panel discussion. For this panel discussion, we have 5 panelists. We will have Professor Wu Zhoukai. So Wu here, based on the podium to the stage. Also we have Professor Kakush, Professor Dean, and Darren here, Singapore Society, one more. Professor Sabandu, Dr. Sabandu, is also panel, right? So please, panelists, please come to the stage, please. As you can see from the program, the title of this panel discussion is Technical Engineering in the Changing World from the Asian perspective. So I think we should start from Darren, from far left. As I know that Singapore, this is a mega city, it experienced a lot of change for the past maybe 10 or 20 years. Maybe you could share with us what are the challenges and what are the major directions for operations in Singapore. Share some of the development in Singapore. Thank you.
Thanks so much, in fact, Singapore, we are a tiny island country. We have quite a fair bit of challenges. I think what that we are blessed is that we do not have as much of a natural hazards, but certainly we do have our share of constructions challenges, being in a very highly urbanized environment. I think also that there are some incidences whereby we have to learn. I think you guys are also familiar about the Nicoll Highway collapse that happened about years back, 30 years back. So I think that we learn from it and grow from it. So I personally feel that for geotechnical engineers, for sure that we need to ensure that that our design is safe, do our best, follow the codes. If we are unsure, certainly we have to prefer to research papers, be the best. It's another way of how that we develop professionally, but at the same time, I think we do our best, but for sure that perhaps some blind spots that we know that could have done better, and some minor construction incidences may happen. What's most important is not to keep to our conservative perspective, but rather is to learn about how they develop ourselves and to learn from all of these case studies and grow from there. So I think Singapore, basically we are a small country, we are a young country, and we are glad that we have many of our Asian countries which are much have small, have a longer runway whereby we can learn from them. And so looking forward to continuing to collaborate with international societies as well as with our own Asian societies, so that we can learn from them, we can reach them.
Captain, I have a question.
Yes.
As I know, about maybe 10 years ago, you have a plan, long-term plan for underground city. I don't know, is that long-term plan still ongoing? Could you please share with us what is the status of that underground space project, long-term project? Thank you.
Yes, indeed. I think we're being a small island country. We're basically land gas. Okay, so land being scarce, we can either kind of develop our cities vertically upwards or vertically downwards. Right? I mean, we are one of the countries that has reclaimed lots of land, but at the same time, we continue to explore our underground space to try to utilize as much as we can while taking note of the safety of the buildings around. So I think basically our underground subway system is rather expensive. We also have deep tunnel sewage systems. Our utilities, maybe whether electrical, water, sewage, all of our utilities are all buried underground. Okay? So we do not have any cables lying above ground, okay? On the lamp post, no. All of these are actually buried underground. Okay? So while we continue to develop our underground space, we are going deeper, and we have to go deeper, right? Because that's the only space, right, that we can go further, that we can develop further. So I think we have tunnels which are more than 150 meters deep, being used for petrochemicals, right? And we are continuing, yes, indeed, to actually develop underground city in Singapore, having underground data hubs, underground reservoirs, and all of this would come with our own challenges. Right? So perhaps in Singapore, the questions that we will ask is, how do we map and to model this complex subsurface conditions in a very densely developed city centers, while at the same time also how do we manage excavation-induced ground movement next to sensitive infrastructures such as an operationally functioning adjacent subway line or even heritage buildings that we are trying to preserve. Perhaps other questions that we will ask is how do we future-proof, right, that our underground assets is able to withstand with time, right? We are not talking about 50 years, right? In the past, we have always been talking about buildings lasting for 60 years, but underground infrastructure is something whereby it has to go beyond that, right? So we are looking at 100 years and beyond. And those questions that are asked, they are not theoretical questions. They are questions that we have the answer now, right? be whether you like it or not, have to have the answers or to our best ability, know as much as possible before even starting our construction, even planning what we want to do. Right, so at the same time, I would also like to highlight that underground space isn't just purely about geotechnical engineering. We also have to work closely with urban planners, with the utilities engineers, with mechanical, electrical engineers. We also need to work closely with social sciences people to try to understand how would humans behave underground. If you are being kept underground for long hours without seeing daylight, without having that natural ventilation, how would our humans function and how would we behave over time? It's not only it's not one day, but we are looking at months, years, people working underground. So I think there are many things that we can learn. At the same time, we continue to explore and learn from countries worldwide which have something of a similar model of what are the things that we can look out for, how are these questions, these challenges being overcome, and we learn from them. So we are always open to collaborations, open to research together. So that I mean that Singapore is where there are lots of things that we need to learn from the long years of civil engineering in other countries.
Okay, thank you. Next, I would like to ask Salvador about the situation in your country. As I know that Sri Lanka also encountered significant change, different aspects. Also, I know that the city of Colombo also have a fast development. Maybe you can share with us what are the major challenges you have and what is your major directions in geotechnical development?
When we take Sri Lanka in geotechnical aspects, I can divide it into three areas. One is problems coming with the natural disasters, especially landslide problems. And because we have very heavy rainfall situation in the country, we have landslides, and also these landslides are connected with transportation. And that is also a big challenge. And also we can't do all the slope protection in India because it's expensive. We may have to do it. And also there are a lot of people who are living in that area. And also we don't have that kind of resources to move them from those dangerous areas. And with the recent past, the things are with the climate change. We have experienced serious landslide conditions, and now actually we have organizations, government organizations, NPRO, and they are doing these landslide maps, and with the support of the local community as well as the foreign agencies. And of course, I think that will be helpful. Second one is we have a lot of dams, lot of reservoirs. They are very old, sometimes over 2,000 years old, and those are mostly done with earth dams. And also the foundation situation of those dams may be deteriorated with the time because of the sea to the foundation. And that of course somebody has to do that kind of collapse, disasters. And I think we should have many more studies on it and rectification methodology to improve the stability of those ancient reservoirs. And the third one, that is about the development related. In the recent past, we have a great urbanization, and we have a lot of development, especially in building sector as well as in the infrastructure sector. the problematic is now because in most of the urban areas, the soil conditions are not so good. And we have to go with deep foundation, and especially we have to go with the pipe foundation. And also urbanization, because the land prices are very high in Colombo, people have to go with basement. That means the deep basement and deep foundation is a common factor in Colombo. But luckily, our rock levels are shallow compared with other countries. Compared with Thailand, our rock levels may be go to very deep. And because of that, we are fortunate that we can transfer our building loads into those rock levels, and those rock have very high strength. And that is one positive point in Colombo. And also when it comes to the expressway construction that is taking place during the last 2-3 decades, we have a lot of weak soil, and organic soils. And constructing over those problematic areas, we need technology. Especially, we have used dynamic compaction, vacuum consolidation, and then DBT, this acceleration of consolidation, and replacement of soil, and all those things are required to build this infrastructure. And those are the challenges and the movement we are facing. And also, in addition to that, because of the situation in the country, economically situated country, there's a lot of trade and a lot of geotechnical engineers move to the developed countries, and that is also one of the problems facing by Sri Lanka.
Now we'd like to ask Professor Tsuoka. As we know that Japan lead in the advances in geotechnical engineering for many years, and also you have two mega cities, Osaka and Tokyo, and you have a new generation of high-speed rail under construction within those two cities. I believe you must have a lot of new challenges and new development. Maybe you can share with us what are the major challenges you have and what are the major development directions in Japan for the geotechnical engineering. Maybe you can share with us.
Briefly, yeah, I'm surprised, so I can't understand why I am. But anyway, so you mentioned about the new express railway between Tokyo and Nagoya. Currently, so we have a plan between Tokyo to Nagoya first. Then we extend from Nagoya to Osaka. So I'm not so familiar with the project detail, but anyway, most of them are underground or in the tunnel. So it's like a dark way. So maybe passengers cannot see the beautiful sea, like to Fuji. So we always go round in the tunnel here, especially for the legacy. So as for we are now constructing the deep railway station and the Shinagawa station, maybe over I'm sorry, I have mistakes of some Japanese corrected information. So maybe over the 50 or 40 meter deep. So in Japan, we have some government rule under 40 or 5 meter, 50 meter depth. We can, government can construct under tunnels, so without the agreement with the residential. So then, so it's very special for the deep ground development. So maybe new express railway use this system. So most of railway is underground. So of course, as you know, that we need most of various kind of technical technology, underground wall or sealed tunnels. So as far as I know, the Japanese construction company major Japanese company concentrated their recent developed technology into this new express rail. And of course, sometimes in the mountain area, we have another issue about the environment of the underground water. So during the construction of the huge tunnels, so as we know, we will change the natural system of the underground water. So sometimes it will cause some environmental issues around the mountain area. So of course we need to pay attention to conserve natural environment for another thing.
Talking about, because the alignment is more deep and also crossing the mountain area with long tunnels.
Yes,
so it's very, as the challenges more difficult than before, right? And but there's another question I would like to ask. I know that the speed of this new high-speed rail is higher than before. So besides those, traditional geotechnical engineering problem, is there any other consideration for to increase the speed of the high-speed rail? Alignment is more straight or
the new express railway the speed is maybe over 500 kilometers. It's like electric magnetic train. So maybe we need more attention about the wind or air resistance. Maybe it's due to the mechanical issue or about development of railway.
Aerodynamic problem. Okay.
Thank you.
Thank you. Let's move back to for David. Maybe you can show us what are the challenges that change in Iran. I know both Iran and Iraq also have a very fast development of engineering, but we have no idea. Maybe you can share with us. Okay, thank you.
Thank you very much. Good afternoon, ladies and gentlemen. First of all, I have to thank the organizing committee for arranging these two panel discussions yesterday and today. It was a very great idea to discussing the problems or ideas from various societies. Regarding your question, of course, yes, as you mentioned, in our country there is a lot of big mega projects are going on related to dam engineering, tunnel engineering, transportation, and so on. And of course, all of these projects are the main parts of this project is geotechnical engineering. And there is very high-level research and also students and facilities working on this field for educating the young generation for being involved in these such projects. But I would like to raise a few challenges that we have in Iran regarding to geotechnical engineering and also some comments. For this I have prepared two or three slides, if you don't mind. Would you please show the... Yeah. Next one, please. Okay. In this slide, I have tried, of course, there is a lot of issues will be discussed, but due to time limitation, I have tried to raise and mention some of them, the most important one. The first one is the effect of climate change in geotechnics. Of course, it is one of the main, problems in most of the countries in the world. But in our country, from 3 point of views, is very dangerous in recent years and decades, which I've mentioned then, that ground subsidence drying of the lakes. For example, Oromia Lake, I have a slide about that, which produces dust storms, which is very dangerous to the health of the people of the regions and big mega cities, Tabriz and Oromia, and also other cities around that lake. Most other, lakes also in my country due to water, climate change is going to be dry. And the final aspect of this is environmental, of course, problems which arise from this. Can you go to the next slide? Just some examples. Yes. This is that lake that I mentioned in the northwest of Iran, Urmiya Lake, which was the biggest salty lake in Iran, or maybe in the region. It was about 24 or 25% salt, which is very high than normal seas and oceans. Unfortunately, in the right-hand side, you can see the time lapse of the drying of this lake from 1998, maybe 1980s to up to now. And could you press? And now this is the situation. Almost this lake, which used to have more than 25 billion cubic meter water, now is disappeared. This is 2023, and in 24 and 25, now almost completely dry. And there is some winds in the region, so it will cause a lot of health problems to the inhabitants around the sea and also to the agricultural fields. Another one, could you please? Yeah. Another one is, as I mentioned, ground subsidence, which is very, how to say, dangerous in our country. Most of planes in different parts, you can see on the Iran map, some dots, red dots. They are the, potential or started ground subsidence areas in our capital, Tehran. It is more than 30 or 40 centimeters per year, very high. As you know, more than 5 centimeters per year means crash. So in most of the planes, and that's also due to climate change, drought, and also using a lot of underground water. And this is the two examples in the plane and also in the city. Tehran city, we have very frequently that kind of, how to say, appearance. So could you go to the first slide, please, again? Return back. Okay. So it was the first one, effect of climate change, which is very important and very dangerous in Iran. And of course, there is some plans for controlling it. Some of them would not do anything. We have to control it and slow it down. I remember that in Japan, 70s and 80s, they had a lot of ground subsidence problem, but now has been stopped almost. Or reduced almost very considerably. A second issue that I want to raise, my time is over, please let me know. Yeah, second one is
bring up a very interesting issue. It's about ground subsidence. It's happening in many countries now. Also due to climate change, but generally it's due to the heavy rain or after heavy rain. But in your country, very interesting, you have a drying of the lake. But my question is that for the ground subsidence, you show the picture, does that happen after the rain or no rain?
No rain.
So your problem is quite opposite than the others. We have too many rains, or for heavy rains. But your situation is too dry, right? Okay, it's very
Too much of the underground waters, they are pumping.
interesting.
Okay, yeah. The second one, which I think also very important, yesterday also I explained about that, paying attention to the young generation of geotechnical engineers. As I mentioned, there is a lot of research, high-level research in my country and also in most of the countries are going on in the geotechnical engineering in different levels, of course, with facilities. But after graduation of these young engineers, we have to be very careful about their professional involvement in the projects and also taking care of them from different aspects, from their legal, rights, their salary, their style of life, and everything. So in Iranian Geotechnical Society, we are very interested to making more young engineers involved activities. And as you know, the young energy, really will push any society forward. So it is very also important. The third point, which I want to talk about it is kind of, suggestion for our society, ISSMG, which is thinking and working for establishing new technical committees. Of course, most of our technical committees are, scientific, geotechnical based. But for example, in Iran, most of the, geotechnical companies usually they have some problems with their clients, with getting their contracts to be completed from especially financial views and so on. So we established the Professional and Legal Affairs Committee, technical committee kind of it. I know that the legal and also professional regulations for each country is different. But its establishment for each country, I think, according or based on their own legal, regulations, could be very useful. We have done it for about 3 years, and most of our corporate members and companies have been very active on that. We have been able to solve some of the legal and professional concerns of that companies. And finally is working on International Ground Federation. As Mark yesterday also mentioned, I know that ISSMG is working on that, but I want to suggest that make it more stronger and do cooperate and common activities, different kind of activities for making it more stronger, that Ground Federation. Thank you.
I think I can comment on that the fourth point. I know we have a committee, ISSMG has a committee, special committee for corporate members. We will have a board meeting the day after tomorrow. I will bring up your suggestion in the board meeting. If Andrew is not here, okay? Can we move on to conclusion, please?
Thank you. Explain something. I would like to explain something about Iraq. Iraq is a very small country, about 440,000 square kilometers. And the soil in Iraq, highly varied soil. At the north, we have mountain area, in addition to the flat area. So the soil in the flat area mostly is salty sand, and there are gypsum soil a lot. In the middle part of Iraq and south of Iraq, the soil mostly salty clay soil. In the
the middle of Iraq, so this clay soil, there are no problem, just the high groundwater table. In the south of Iraq, we have soft soil of unconfined compressive strength less than 1 kilopascal. Also, in the west area of Iraq, we have a lot of gypsous soil, and the gypsous content varies from 10% to 80%. Sometimes say it is gyps, not soil. So the variation in the property of soil need to take different consideration in construction of projects on such soils, such as we have Mosul Dam constructed on gypsous soil more than 40 years ago, and the grouting is continuous from the construction till now and continuous till the end of the project. This is one of the problems that we are facing in Iraq, different types of soil and we need different concentration. Also, high groundwater table. The second factor affecting the construction in Iraq, the extreme in temperature. In winter temperature about 0 to 10% centigrade, and in summer temperature about 55 centigrade. So it is very high degree of temperature for construction and other things. So mostly construction is stopped at the day and continue at the night to avoid high temperature degree. We have in Iraq several problems before. One of them also is Iraq mostly historical cities. So city constructed over city. In the previous, till 20 years ago or 15 years ago, most of construction not increased about 15 to 20 floors, about 40, 60, 70 meters. But now we are going for construction of building 170, 180 meters, using new technologies of construction such as diaphragm walls and wood pile. The problem in the old cities, we cannot construction new buildings due to the restriction of the soil under the building. Almost is not soil. Almost was houses and stores and others. So constructed, if you know that the history of Iraq extended to 6,000 years before. So a lot of civilization come to Iraq and a lot of construction cities in most of Iraqi territories. So nowadays we are trying to apply the sustainability concepts such as economy, social, in addition to environment, also natural resources, because some of construction materials are not available locally, so insisted to import it from outside of Iran. In Iraq Scientific Geotechnical Society trying to play an important role in encourage people to apply sustainability pillars, also to apply seismic codes in designing buildings. Iraq is out of seismic zone, but sometimes affected by earthquakes event in Iran and Turkey. So in the last 10 years, 2 or 3 rebounded earthquakes hit some buildings in Iraq. There are no big damage, but almost we need to precaution about the construction of new projects. In Iraq now, we are going for construction a lot of projects. Some people till now afraid from construction underground. So we didn't have underground structure. If we know that metro of Baghdad was planned from 80s, but till now not constructed. They are afraid from construction underground due to the different layers of soil, also the high groundwater table.
Following your presentation, I have a question about the new development. You mentioned about that your building is deeper and deeper, right? For the old city like Baghdad, you must have antique stuff, antique layer, right? Do you have this kind of problem, or I mean, when you dig into the antique layer, you stop your construction. You encounter this kind of difficulties, and how do you handle that?
Yeah.
In Iraq, mostly not talking just about Baghdad, all center of city, mostly you cannot construct a new building because already there are different layers of soil also restricted and prohibited. Sometimes we need to keep heritage. Also, some cities outside Baghdad. Same thing.
Any questions from the audience? Okay. Rogelio.
Yeah, this is not a question, but I'd like to give you the information about the International Ground Federation. You mentioned that. We already have that platform. Well, as I mentioned, as I give presentation on the first day, we have Federation of International Geoengineering Societies. So ISSN is already the member. So under the umbrella we call FedEx, that's federation. If you want to create a committee on some special subject, then you can propose through the ISSNG. Then you can have a platform to work with other rock mechanics and rock engineers and engineering geologists and geotechnical engineers. So we already have a platform. I think that we can utilize that. That is my information.
Thank you very much for your explanation. Yes, I'm aware of that. Yesterday also it was mentioned, and that's a very great idea. Recently also in Iran, we have formed a national ground federation, which involves geologists, tunnel engineering, rock mechanics, and even water resource engineers, and of course geotechnical engineering. And yes, I believe that it will be very useful for the ground. Thank you.
Thank you. Derek, any more thing you want to share with us? Second round.
Okay, so this is something, and I think this is something which is affecting many of the industry, including geotechnical engineering, which is on the digital transformation. So, this is something that I believe is that we have to embrace. Just to share with you some history or background about myself, and perhaps that you all may think that I'm young, but I do have my resistance back then, trying to embrace AI into my research. So I was just thinking about that. The AI is just here for a short while, and everything will still go back to normal. Everything will have to come back to fundamentals, which is what that we are comfortable with. But in Singapore, we have been pushing a lot on AI, how that AI is able to facilitate constructions, and being an academia, you have to go, isn't it? To get grants, to get money. So basically, I have to go with that flow to try to do something relating to machine learning, AI stuff. And that is a time where I learned something that, in fact, AI is not used to replace us, but is to complement what that we are doing. I just have to stress that don't worry about AI, especially in our industry, right? Unlike other industries, perhaps, but I think in terms of geotechnical engineering-wise, it is still a discipline whereby it's heavily dependent on the opinion of the designer, right? So, as we continue to face this growing complexity, my own view is to embrace these innovations, digital transformations, and across Asia, in fact, being in Asia, that we can really see that AI is in Asia. Asia, we are perhaps one of the strong hub when it comes to AI and machine learning. And if you were to just Google, these keywords, relating to soil classification, about risk management predictions, about soil properties, I think you'll see a lot of these papers coming out. And it's about how we are able to incorporate into our design. My own very narrow opinion is that as you look at these papers and you gain more confidence in AI, right, then what's next? So my personal view is that when it comes to AI publications itself, by reading these papers, is it enough? Have you really elevated yourself to be able to we always talk about, when it comes to research, it's about being able to reproduce, right? And after reading an AI paper, machine learning, can you reproduce what that paper has discussed about? Or rather, perhaps, is the majority of us already up to a certain proficiency to allow us to read papers and be able to learn from it and adapt into our design and our research? If the majority of us are struggling with reading AI papers and thinking that it's a good paper, but there's hindrance to how that we can apply to it, then perhaps that we can try to link papers to GitHub. For those who are working on Python, GitHub is a very useful resources. But just about thinking about that, do we need to actually create a kind of like a repository? It's the same thing as constitutive models that we are now very familiar with. Back then, we only have just a handful of constitutive models. But these days, we have hundreds, we have thousands of constitutive models being published, right? And the very established ones tends to be incorporated into our numerical modeling. So the next step is, do we need AI to actually move in that similar direction so that the majority of geotechnical engineers, I'm not talking about academics, but talking about day-to-day geotechnical engineers in a consultancy or construction firm, are they actually ready for AI that we are trying to push out? If no, then perhaps there is a gap that we need to close. Yeah. So perhaps this is something not only in Asia but also perhaps in other parts of the world that we can maybe think about. Are we just only contented with publishing in top papers, in top journals, in AI, and we're happy with that? Or do we want to translate this into something more tangible that practicing engineers will feel grateful about? Now they have an additional complementary tool that they can apply into their design and to improve perhaps safety or to complement on traditional geotechnical design methods. So these are perhaps something that we can all think about, and feel free to share your thoughts. Thank you.
Okay, I think we're in a very hot issue. A lot of people argue about the application of AI. Anyway, any comment from the audience? No, let's.
Good afternoon to the speaker. You have touched very burning issues so far, geotechnical engineering is concerned, because everybody is required to use AI and ML techniques in various analysis and designing process, and they are very much dependent on that process. But actually,
So thoughtful discussion and very contemporary ideas we need to propagate to the ITC's engineers and researchers. Thank you from my side.
Thank you for your comment. As I know, SSNG will have another panel tomorrow. We'll focusing more on the application for AI. You're welcome to listen to further discussion. Thank you. And
about AI also I have shown AI is a good tool, but you have to use with precaution, with caution, because the experience and the fundamentals are more important, and AI will be a assisting tool for the development and fast solutions. Otherwise, it will be sometimes can be a disaster. And also about my comments what I made about Sri Lankan situation, peat soil is a real problem in Sri Lanka. I mean, it is not like organic soil and marine clay in other countries. And in some of our areas, the water ratio, water content is more than 5. And we need a special kind of treatment to improve it. Now, the new highway from Katra Airport to Palan is 25 kilometers, and we have this kind of peak around that is done. So far, we have no problems, but we need special kind of treatment to overcome that situation.
I know that recently Japan experienced a tremendous impact from geohazard, like earthquake. Also, people talk about potential big earthquake in southern Japan, and also I know that recently there's abnormal rainfall, heavy rainfall, also induced surface subsidence, right? In different cities. You have any comment on those geohazard, and what are the research or development in Japan focusing on geohazard?
Yes, thank you. Yeah, in the yesterday, like you talk about the climate change and about different pattern of rainfall, so comparing with the previous pattern. And in addition, in Japan, we have a similar situation. We have a big trough along the Pacific Ocean. So sometimes we have experienced earthquake and rainfall and earthquake. But unfortunately, during rainfall, earthquake will happen. So this means that we call the compound or combine the disaster with the rainfall or earthquake, and or sometimes earthquake and rainfall mean the cascading. Yes. In the 2024, not earthquake, but earthquake. So earthquake occurred in January, and heavy rainfall occurred in September. So some area was damaged due to earthquake ocean. So it means that earthquake will cause more severe damage. And it's very severe in Taiwan or other countries. So then, basically, including me, the Japanese Geotechnical Society focused on the extreme effect of the natural hazard. So extremely large earthquake and extremely heavy rainfall. And sometimes we have to consider compound effect. So this is my list direction of this rainfall or earthquake compound disasters in Japan.
Thank you. Before I close this session, I would like to share with the panelists and also the audience about what we experienced in Taiwan. We also have surface subsidence problem, seriously, in many cities. Yeah, but the problem for us is heavy rain. But if you, maybe some of you listened to my presentation before, I show two figures. One figure is average annual precipitation for past 100 years. And annual precipitation is almost the same in Taiwan for the past 100 years. But the rainy day reduced significantly, means that rainfall is more concentrated. Also, not evenly distributed. Some area, some watershed, or rainfall, some watershed, no rainfall. So we experience drought and flooding together. Some area short of water, some area too much water. But this kind of situation not only induce the water shortage for serious period, maybe 2 or 3 years ago, the capacity of the reservoir down to 5%. So we don't have any water supply. We only supply the water 2 times a week, very serious problem. But 2 months later, the capacity back to 95%. So this kind of unstable situation, fluctuation also create opportunities. We are now building water diverting tunnel to pump the water from watershed to watershed. So this is also an opportunity for us due to the impact of climate change. But also due to this kind of situation, we also have a lot of surface subsidence incidents. We also did some research, but actually the reason for those surface subsidence, there are many different reasons in different areas, different geology, different quality of pipeline. So there are many possible reasons for that. So we can share that you are interested in that. Before I close the panel discussion for the outline, briefly, okay, last minute.
Thank you very much. Regarding AI, I remember in the last 17th ARC in Astana, one of the speakers asked if you ask a machine and get answer, and ask the technical expert in geotechnical engineering and get answer, who will, in what will you will believe? In machine or a trust or believe? In machine or in experts? Most of people say we believe and trust in expert because machine means computers, means software, means designer, means users. So there are a lot of people, they have different ideas and different things. Also the soil is highly non-homogeneous material. Even their equations did not apply for all. So there are a variety of variables that we should be taken in consideration. Also at this moment I will build all use last technologies such as thermal tiles, geothermal techniques in production of electricity and heat. Also we have bioremediation in soil because we have a lot of contaminated soil due to conflict for long years. So we can use bioremediation, which is more sustainable techniques and more environmental friendly techniques. Thank you very much.
Let's summarize what we are talking about here. We're going to talk about the future application of underground space in Singapore, and also you bring up the issue of application of AI. Very interesting. Maybe we have to discuss that more. Also, Professor also talk about the new development in Japan, mega city, high-speed rail, and also the combined disasters is quite challenging. And also, Takushi talk about the new challenges in Iraq, and also you also make a comment on the application. I think of AI. I think it's similar to the idea Professor Zhang bring up yesterday. We have to take a balance. We cannot, only depend on one thing. It would be dangerous because it might not mature enough. But we have to be careful about using AI, machine learning, and also Dean talk about the development in Iran, and also a lot because you are strong for quite some time. Also, your impact of climate is very interesting, very different from ours. So I think maybe we can find some insight from this kind of challenges further. And also, I do talk about the new development in Sri Lanka and also the foundation, new generation of foundation in city of Colombo. I think also interesting. I believe through the efforts of engineers and especially young generation, I think of course I believe that Sri Lanka also will make a contribution. If foundation, especially in the South Korea. Thank all the panelists who attend this panel discussion, also the audience who join us. Thank you. Thank you very much. I would like to close the discussion. Thank you.
Thank you to all the panel members and the moderator for a very interesting and engaging discussion. To present the mementos to the panelists, I invite the moderator, Professor K. Jian Shu. I request Professor K. Jian Shu to present the memento to Dr. Darren. Thank you. I request all the other panel members also to join the same line where they are standing so all of you can be seen. I request Professor K. Jian to present the memento to Dr. Mendy. Request Professor K. Jian Shu to present the memento to KLS Sagundo. Next to Professor Fardeen. I request Professor Yusuke Yusako to accept the memento from Professor K. Jian Shu. And now to present the memento to our moderator, Professor K. Jian Shu, I invite Dr. A.P. Singh, the Honorary Secretary of Indian Geotechnical Society. Thank you all. We now have the panel sessions. Tea is also arranged outside. In Assembly Hall 1, 2 and 3, we will have a 15 minutes delay. But in all the other halls, the panel sessions will commence at 4:13 p.m. And I have two announcements. All the delegates who have registered for today's gala dinner, please assemble in the hotel lobby at 6:45 p.m. Also, please carry ID cards. Please carry your ID cards along with the coupon that has been given for attending the gala dinner. So all those who have registered, please assemble at the hotel lobby at 6:45 p.m. Also, please carry your ID cards. Tomorrow morning, the last day of this conference, we will commence sharp at 8:45 a.m. Request all of you to be present. And presentations, please hand it over at the console so that we can start sharp on time. On behalf of the organizing committee, Geotech Asia, we thank all the sponsors for helping organize this wonderful conference. Thank you all.
Because it is very burning.
Some of the officers, and also entry level lose their job. And then the problem is that the young people don't have any chance to experience the entry level job. So I think we should discuss change it to certain point to protect our professionals.
Can we have the picture?
Which one? Yours? First. Yours? I can give it here. Hey, Bobs. Is it on?